Without further ado, let me introduce Dan Isaacs, because Dan's going to take over the MC role for this next bit. Dan's the Chief Technology Officer of the Digital Twin Consortium, and then he'll introduce his panel or let them introduce themselves. So Dan, over to you.
Great, thank you, Barbara. And thank you for this opportunity to moderate this panel with our esteemed panelists here. With that, I really think we'll just jump into it in consideration of the time. We have Shelly Nooner, who is the Global Civil Design Engineering GM at Trimble. We have Peter Atalla, CEO and founder of Voxelmaps. And we have Bill Singleton, who is the VP for Ecopia AI. So the way we'll kick this off is we'll just start off with each of you giving a little bit of an introduction about yourselves and the role that your company is playing relative to spatial digital twins. And then we'll go through a couple series of questions, and then we'll open it up to the audience. So with that, Shelly, would you please start?
Yeah, no problem. So Shelly Nooner, I'm the General Manager of Civil Design and Engineering. I have been with Trimble 21 years. I started my career in the geospatial arena, so I have a big heart for all of you. I know some of the people on this call, so it's super nice to see everyone. I have thus moved forward in my career into civil infrastructure. And what we are currently focused on is helping provide what I would say is real-time attribute information, both context to the geometry around the construction build, which is extremely valuable when you're looking at spatial digital twins. Never what was designed is what gets built. And so that has a lot of value when you are looking at maintaining an infrastructure asset long-term and can help you rebuild better. So that's my focus and my use case today. So thank you for having me.
Excellent, thank you. Peter, would you like to go next?
Sure, good morning. Well, hello everybody. It's a pleasure to be here today and have the opportunity to take part in this panel. So my name's Peter Atalla. I'm the CEO and founder of Voxelmaps. And at Voxelmaps, we're building out essentially maps for machines. So these are very, very accurate models, essentially creating digital twins of environments, including cities, inside buildings, and even into forestry as well. So we build a 4D volumetric approach to this, meaning that we can map the interior spaces as well as the exterior as well, and really help to facilitate not just humans using digital twins, but for machines, including autonomy, like robots, for example, to really understand that space as well. So my message as well is machines need digital twins as well.
Great, thank you. And Bill, please.
So it's a pleasure to be here. Thank you all for taking some time this afternoon. Really enjoy the opportunity to be presenting with Peter as well. In terms of what Ecopia is focused on is really using AI to be able to convert massive amounts of optical imagery into the base maps that are going into local government, federal government, and also civil engineering. So really where we want to be focused on, instead of being very focused on a city scale digital twin, really being able to create a standardized data set across an entire country and keep that up to date as frequently as possible using satellite and aerial imagery. So looking forward to the discussion.
Excellent, excellent. So with that, I mean, we've been hearing a lot about the different types of digital twins. I think from the report, we saw the different tiers and the structure of that based on the different elements, the different areas. We heard some discussion a little bit about the metaverse. I'd be curious to hear your thoughts relative to steeped in reality, but now using that digital twin, the spatial digital twin, as the representation, your virtualization in the metaverse. So maybe, Shelly, you could talk a little bit in that context.
Well, I guess I would think it's going to continue to evolve, right? Mm-hmm. So I think one of the things that's going to be interesting as we move forward in the meta universe is the more information that comes in against objects, right? And the use of that and the stakeholder use of that. And I think, it's it's going to be interesting just to get a starting point where we see some real, I would say, action and ROI against a spatial digital twin. A lot of the people who, honestly, in civil infrastructure, where I'm heavily involved right now, it's so much to contend with. They're just trying to find a place to start. You know, they're looking back and they're trying to get forward in this space, right? Massive amounts of data. And it's really pinpointing where they need to start so that they can actually get use from a digital model where they see the value. You have to see the value pretty quick to keep it up, by the way, because it's very easy to turn around and go backwards and use what we've always used. So I think if you throw a lot like meta universe out when you're talking to a public sector owner, they panic immediately.
Right.
So I think you have to help them on that journey to get them to the place where they're going to see that there is so much more information that's going to be coming in that's going to be useful for an output one day. So.
Mm-hmm. And how are you seeing that, Bill, relative to, you know, your goal with the large data set, obviously, that we're talking about here?
Yeah, so in terms of what we're seeing is, I mean, there's so much data that's available, even on the optical spectrum, like satellite data, aerial data that's being released every day. Just even helping people try to get their arms around keeping everything up to date. Really where we want to do is be able to remove the act of digitization. So often you have issues where even before you can start to drive to those insights, there's a lot of work that has to go into that. And when you work with things like open data, I think we all have experience where you have thousands of contributors from thousands of data sources. It's just not something that you can rely on, especially in the civil engineering space. And so really what we want to be able to do is create something where you have a standardized data set using stereo optical data so that you can at least allow people to start to get to work faster is the best way to do that. And so really what we want to be able to do is create something where there's a base model where people can contribute on top of that, where it's not necessarily like OpenStreetMap or some of the other open data sets that are out there, because there's just so much inaccuracy in some of that. And so really what we want to be able to do is just create something that's standardized, because it's so unfortunate when there's so many siloed data sets out there where people are creating their own models, but they're not necessarily getting shared. So that's really where we want to be.
And I guess, Peter, from the standpoint of Voxelmaps, I mean, the tagline is from what I've seen, is building the world's most accurate maps and using 4D. And how do you see that being manifested within the metaverse?
Yeah, no, it's a really good question, actually. So the first thing I would say is when we look at computing in general, there's a big macro trend in terms of computing going 3D. And if we break that down, there's really two, versions or two worlds of that. One is virtual worlds, which is very much metaverse, and it does spill over into our physical reality as well. But the other side is what we kind of call reality capture. And fundamentally, these are quite different in the approach. So really, when you're looking at virtual worlds, this is a 3D data set. Reality capture really is a 4D data set. And I kind of feel, the kind of the industry in terms of digital twins at the moment is very much on version 1.0, right? It's like, great, we've got a 3D model, we can attach a few sensors to it, this is really cool. But really, when you're looking at doing this at scale, like Bill's talking about, entire countries, entire planets, you need a data model that can facilitate that level of data that can do 4D change detection within it at a planetary scale. And that involves handling thousands of petabytes of data. So the approach is different. And really what we've done at Voxels is to tackle that. How do we build a platform that really can scale to be planetary? And at the same time, provide that kind of global reference frame, because Bill's point is absolutely spot on. You kind of have these relative digital twins. They're all relative reference frames. They don't kind of line up very well. How do you piece it all together, whether it's a building or a city or whatever you're trying to do there?
It's a great point. And I think that comes back really looking at it from perspective of being able to accurately represent these environmental scenarios, whether it's the city or scaling out to entire country, or as you were saying, and we heard about an example early on with Destiny, right? The approach of the entire Earth. How do you manage that high volume and velocity of data that's continually changing? How do you see that relative to the data capture and from the analytics aspect as well as the visualization to ensure there is that level of precision and requisite fidelity to between the virtual and the physical?
Sorry, that's me?
So back to you from the 4D perspective, and then I'd like to hear Bill's as well, because now we're talking about,
Big
data
question.
on a planetary scale.
Big question.
Absolutely. So in short, you can't, right? If you look at the standard approaches at the moment, they're not really fit for this purpose. So if we look at standard 3D data, we've got points. Points can be great, they're very accurate, but super unstructured. And you really kind of, once you've done your processing, you kind of archive them off and you don't think again. And then when you think about meshes, I mean, the real reason we're using meshes in geospatial is they're lightweight, and the games industry has provided us engines that enable us to use it. Mm-hmm. But when you're looking at trying to do this at scale, you need a new structure for a database. And so that needs to be structured. It can't be completely unstructured like points. And so that's why we settled on using what we call voxel occupancy grids. And essentially, it's a way of cutting the planet up into tiny little cubes, essentially, and then referencing this data. But the good thing is it has this temporal component to it as well. And that database structure then allows ML to be integrated into it directly to perform very fast calculations at scale, which is something that, if you're now starting to handle, 100 petabytes of data, most databases are not going to stand up to that. You need a different approach. And so that's kind of what we tried to do here at Voxel.
You want to comment on that, Bill?
Yeah, so in terms of managing it, I mean, we could go back to the infrastructure piece, because to Peter's point, I mean, if we're going to even talk about, should it be customer centric in terms of on site? So there's a lot of different issues that you have to sort of address once you start to think about either a national or a global data set. I'm going to sort of stick with national or even city scale. So we create vectorized data, which is a lot lighter than working with sort of the optical pixel imagery that you're typically used to. But even in that sense, we want to create a method where you can either have it on site or we can actually host that for you as well. So it's one of these issues where the biggest cities always have the most resources, but when we start to standardize across an entire country, what we end up seeing is you have tertiary cities or secondary cities that don't necessarily have those same facilities. And so really that's where you want to be able to create something where they can access it at their will, and whether it's on location or not on location. So, I mean, the storage piece alone is a huge issue.
Shelly, from your perspective, where do you see some of the challenges related to this? Obviously, where Trimble is.
Yeah, I think you've got to look at extensible cold storage, location based, right? I mean, there's so much data. It's, and who's going to be using it and when they're going to be using it and when do they need it and, things like that. I think, the other thing is, I think on the storage and the hosting capacity, there's also a security element that I think is also going to be thrown into that mix when you look at doing national networks. People don't want that information. I think you're going to see some, probably blockchain activity that comes up at some point, right? Because you don't want someone to get all of that data, their hands on all that data. So I think, just like your streaming services, it's, closest to you type of thing. I think there is a lot of, I would say, tech and progressive minds on how to do this for other industries that we could leverage in what we're going to be doing. So
that's a great point. I guess being able to look at, as we heard earlier, look at this from the perspective of digital twins growing out of the manufacturing environment, continuing to evolve, obviously, but now extending into the other areas. I like the way it was described in terms of the hype cycle, where there was really a technology piece to that, but now there's an application pull that's pulling it out of that trough of disillusionment. So I think we're starting to see that. And I think some of the examples you just gave are indicative of that and being able to leverage those as that continues to evolve. I guess the same question I posed to you, Bill, a little bit in terms of the challenges that you see and how those challenges really, what is that going to look like, 3-5 years from now?
Well, one of the biggest challenges is, of course, and I think it's been echoed all through today, is that standardization piece. Mm-hmm. So it's being able to capture data where you do want to crowdsource, because that is the most efficient way to collect as much data as possible. But then you have issues where it's not something you can rely on. Right. So it's really about trying to create something where it's a standardized approach where you have a data set that can be relied on, but is still kept up to date, maintained, and the same wherever you go across the country that you're looking at. So one of the challenges that we see is it's unfortunate to see how many silos there are, even within a single government. So I've seen data sets that are created at a state level, a municipality level, and then you have an open federal data set. So it's just unfortunate when you have so many, I guess, people are doing the same work over and over again. And so what you want to be able to do is create something that everybody can have access to and then build upon. So that's something that we see as a challenge, is not duplicating work in a scalable fashion and making sure that it's kept up to date.
And then maybe, Peter, from your perspective, relative to the 4D aspect of this, where do you see, are you seeing also a similar situation in terms of standards? And I would think the garbage in, garbage out scenario plays out very well here too. So your thoughts here?
Yeah, no, some really interesting points. So, as Thomas was talking about that whole concept of the Gartner, hype cycle and kind of where is it? And I very much feel that we are kind of heading, unfortunately, into that little dip, at the moment. And I think there's a couple of reasons for that. I think primarily, to Bill's point, absolutely, 100% agree with what he's saying there. But I think engagement, right? I think a lot of people's approach at the moment with digital twins is, doesn't it look cool, and it's 3D and it's great and it's a good like flagstone project, but then does it integrate? Are the users really fully engaged? Are they using it day to day as part of their workflow? And in a lot of situations they're not. And so we've to really create that value, to kind of get up past that drop, that point, you need to look at engagement. And then I think, together with that is the concept of autonomy as well, right? How can you just, rather than just represent data and visualization, how can you start to get these, the ML, the AI that can sit on top of it to take automatic action through different sensors, IoTs, even, into smart infrastructure as well. And so we start to see that happening, and that needs to be underpinned by standards. So, the conversations today around standards is really cool. Personally, I think we've got a few years to go to really kind of get people on board. And I know probably people don't want to hear that, but we've got a lot of work to do. So it's great, to have all of these companies and sort of people talking about this and pushing it forward.
And that's a perfect segue in terms of the next question, is really that automation becomes a very key role, even to the level that you have digital twins effectively managing their own communications, and at frequencies that we wouldn't be able to be involved with because of the amount of data, the velocity, as I said, the veracity of that data. So that communication, where do you see that automation coming into play, and what does that look like in terms of going forward in the future? You're going to have autonomous digital twins. They're definitely going to be communicating, especially from the standpoint of a system of systems type approach. But where do you see that? Where do you see that heading?
So I'll give you one example, which is quite interesting. And we're based, our head office is in San Francisco, and in a way, sometimes San Francisco is a little bit of a bubble. It hasn't kind of rippled out everywhere. But in terms of autonomous systems and autonomous vehicles and how they interact with the city, so all of the autonomous vehicle companies are really building their own HD maps / digital twins of the given area. But we see, particularly in things like delivery robots, So these are the smaller robots, that go to people's doors and deliver, goods to them, that kind of last mile. Well, now there's a requirement for these to actually go indoors, so into spaces within buildings and deliver inside buildings. So if you imagine that map, the concept of what the machine has to understand, it's not just a highly accurate map of the city and where they can stop for a few minutes to do delivery. It's also how can they go inside a building, navigate around it, where will they be dropping those things off? And that requires a different level of a digital twin and autonomy to be integrated into it. And we're building out, solutions for customers in San Francisco around those use cases. And the nice thing is they're actually collecting data as well. So kind of, to Bill's point about sort of crowdsourcing, but it's more sort of robotic crowdsourcing in this case, that they're actually collecting data, and that data is actually useful for helping to update these models and digital twins.
Back to you, Bill, in this same context, where do you see the automation going in terms of spatial digital twin, the importance and the role it's playing?
Yeah, so just in terms of, it's such an overarching question. In terms of the mapping space, I always think that automation is not the end all be all quite yet. So there's always going to have to be a need for, especially when you're talking about digital twins and 3D mapping, QC, quality control, and a feedback loop of information to make sure that that kind of mapping is as precise as possible, so that you can offload some of that last mile LiDAR capability that Peter was talking about in terms of the crowdsourcing of those robotics. So really what you want to be able to do is ensure that you have the most precise model. But at the end of the day, whenever you're working with remote sensing data, even with LiDAR, there is always going to be a need to have some level of editing to that so that you can ensure that you have that human level quality. And I think that's one of the things that I wanted to talk about is you always want to make sure that automation is not at the point where you can just try to automate everything. Now, are you talking about location data and some of the other interesting things that you can pull from that kind of information? That's a sort of a different subject, but just wanted to talk about in terms of building that 3D environment.
Shelly, what are you seeing on your side?
Actually, I recently was in Europe and I saw a very interesting no lanes and the use of a model and load-bearing roads to say, okay, now we know what 3 to 5 looks like. And what you saw was a lot of confusion. So you almost have to retrain the humans, right? To think, okay, you're still going to follow the lane. The lane's just going to switch at any given point based upon what time of day it was. And it was a much more efficient use of the road, by the way, but it was very interesting. And I thought, we're not there yet. We're not there yet. And I also think back to what Bill said, there is a precise accuracy you're going to have in real time for this to really, really be effective. And when Peter was describing going in a building, I was like, how do you navigate the people that are going to pop in and out and move, right? So it's constant and has to be real time. Do I think we'll get there? Yeah, because I think a sensor can go on anything. But I just don't think we're there yet, but we can get there. And I just wanted to make one comment about the standards. I love the standards, except standards are a framework. They're not your content. And so I think when people stop and say we're waiting for a standard, you can keep going. Standards will help your framework. They will not help your content. You really have to focus on kind of backwards integrating what we're trying to get to. And building, I think data models and data schemas are much more important than just a standard, actually, as we move forward too. So.
And that's a great point. And some of our members basically say, look, there's going to continue to be innovation, and it will be at a faster pace than the acceptance and approval of standards. And what is important is being able to have that ability to adapt or connect to these, right? So build those bridges between those different areas, and then from that progress towards those standards. And we've seen that repeated time and time again throughout these different areas and different applications. And are there aspects of these areas of the digital twin that could be leveraged I think we had talked about leveraging some of the insight and the opportunities that have been now manifested through digital twins in automotive manufacturing, for example. And now how can we look at that, learn from that, and evolve these and continue to evolve? And standards play a big role, but you also still want to keep that. And we see that innovation continuing to drive that. So no, this is great discussions. I guess one of the things I'd like to understand is if we look at it, and I think we've heard about this already, we've heard multiple people talking about the privacy and the governance of this data. And now we're talking about looking at it from a smart city perspective and scaling, even from, as we heard, we saw the example with the Center for Digitally Built Britain with an entire digital twin of the UK, right? The importance of ESG and how that role plays into it. I'd like to understand from your perspective, how you see that moving forward. And again, looking at it from the future of the spatial digital twin, where do you see the main challenges in terms of implementing and actually operating a digital twin in terms of that ESG? Who wants to take that first? I know there's a lot there, but if we look at it from the governance aspect, let's say, right? What are you seeing? Maybe Bill, from your overall data set.
Yeah, so I can just jump in quickly. I mean, there's a big distinction between asset monitoring and location data, and they're very powerful if used properly together. From our perspective and what we're used to is more on the asset side. And to tell you the truth, I don't think that there is enough asset monitoring in terms of the municipal aspect. I mean, just being able to understand the quality of roadways and understanding where certain pedestrian right-of-way aspects are. There's a lot of municipalities who don't have access to that kind of data. So the way that I would look at the world is there needs to be more frequent data capture on that end. But again, the location monitoring is a different aspect.
Mm-hmm. Right, because now you're getting into the privacy of that data and who actually owns that data, right? And who has access to that? Because there's different aspects associated with that relative to security and even the trustworthiness, if you think about that. So maybe Peter, from your perspective.
Yeah,
you're talking about going inside buildings now, looking at that.
Absolutely. So I mean, there's a bunch of issues around that when you're collecting this kind of data as well. I mean, so just from the point of view of personal information as well, when you're collecting, so you've got to undertake to remove people from the scene, identifiable information, at least blur it out if you have imagery. Maybe a little bit less of an issue with some of the LiDAR collections. But core to the concept of what we do as well is the ability to have private data sets. So data sets that are hidden or locked from the point of view of anything else. So certain buildings, for example, in our 3D models, 4D models, you can't get access to for that interior data unless you were to log in with the credentials that would give you permission. So security does need to be built into this. And actually, it's really interesting that Shelly mentioned the point earlier on about potentially the integration of blockchain. Blockchain from the point of view of ownership and the way to track and have accountability over the data. That's certainly something that I think at some point will be integrated. It's future gazing a little bit, but it makes a lot of sense as well. So definitely there's work to be done. I think there's that's the message that we would say.
And Shelly, any points to add here?
I think if you've ever read an asset management plan and you see how many failures are allowed, I would love to know that somebody knows I'm going over that bridge. So I think there is something to be said about reframing the education around what data and how it's used and in certain contexts, right? So I think that's a big thing, right? People are more worried of you're collecting my information, like Peter said, and you're not actually, you're collecting my location. And what is that relative to, right? And, if you look at travel and roads and bridges and things that I deal with all the time, that's a very interesting concept to link those two. I think I was talking about spatial digital twins with one state in North America, and one of the directors said to me, listen, I have a public relations problem. They don't like construction. And I said, oh, well, that's interesting, because you could combine a digital twin of your construction project in real time, with your traffic patterns and reroute people, and you've dealt with your public relations problem. So there's all these use cases to get somebody to launch on starting somewhere in the use of a digital twin. But, like I said, if you ever read an asset management plan and they are very heavy, I would want somebody to know I was going over a couple bridges.
Yes, definitely. We actually have some members doing exactly that, digital twins of those types of structures from the standpoint of structural integrity.
Mhm.
And being able to, and this we really hadn't touched on a whole lot of it, but in terms of predictive maintenance.
Yep.
And being able to identify based on these different types of scenarios, reaching these types of thresholds, then triggering, hey, there's a situation that you need to be able to address one manner or the other. Either avoid it or go in and, as you said, okay, this area is going to be off limits until we can figure that out. So maybe from the standpoint of predictive maintenance, I guess from your perspective, right? You're talking about the asset management, and also Bill, you're talking about the assets in that. How do you see a spatial digital twin going forward in the future being used in that context? Do you see the metaverse coming into play where you're able to see and run simulations faster than real time, and then be able to recognize opportunities for improvement?
Absolutely. I think if you look at objects that make up an asset, they change with me. I will say, number one, I think you can look at autonomous maintenance operation, right, which is a big safety feature when you're talking about some of these environments people get into. I think the second thing is your infrastructure is either being maintained or it's being redone, right? And how are you ever going to build better unless you know how something performed? And so there's this whole, link there that says, okay, it is about maintaining this very old infrastructure in the world or building new infrastructure. It's about how do you make it sustainable going forward? How do you make it better? What is the deterioration? What is the treatment? What was the environment? All of that is attributes of that object that you can collect. You can collect it autonomously, right? So, I think there's this constructible piece to design that can come into play in the future if you have a very good, kind of starting on you're using a digital twin for maintenance. So this is near and dear to my heart, by the way, as you all can tell, like I can launch on.
Exactly. Well, and that's one of the big values that digital twin does provide, is it gives you that holistic view from a historical perspective, those types of attributes, understanding that, to look at what the situational awareness or the event intelligence is telling you at this given point in time, to have a very high level of confidence to be able to ensure your simulations and your predictions are as accurate as possible, because you have that entire spectrum of areas. Maybe Bill, you could comment relative to the data set and how you see that interchange occurring.
Well, just in terms of the simulations, I think the most important piece is to have a standardized model in terms of the data set. And so I think there's so many communities that are sort of forced to use open data sets or information that has been created by multiple users. And so, we see this in the insurance industry all the time. When you have even just address data, a parcel-centric address point is not really telling you the whole information of where that property is in terms of the floodplain. So like there's a lot of information that, sort of to the earlier piece of the conversation, garbage in, garbage out. If you don't have a model where it's something that is standardized across the entire area, then it's very difficult to really start pulling additional insights out of that information, because you don't really have a standardized model to build upon. So that's really, you want to be able to create something where all the information is normalized to a standardized piece.
That's a great point. And how do you see that, Peter?
It's interesting. We do quite a lot of predictive analysis already. So again, when we talk about maps for machines, one of the examples of machines are computer models and AI to better understand cities or a given environment. So one example is vegetation management around assets. so where you're getting kind of grow in or fall in from trees into electrical infrastructure, which can be devastating. They can really cause, wildfires and many, problems, cascading effects, etc. And so we have a network of sensors that is always collecting a combination of LiDAR and cameras, and that gives us time series data. So one, we can see the immediate problems, where there is direct maintenance, but we can also create a predictive model as well and kind of say, listen, these are the areas that are going to cause you problems in the near future. So then the companies can go out and send teams to deal with that. So again, just another sort of example of using that kind of approach to the management of the assets as well.
It's a great point. We have several members that are actively involved across many different domains that really are very heavily involved in that predictive maintenance and being able to really reduce or minimize or eliminate unplanned downtime.
Yeah.
And that unplanned downtime can be across different spectrums and different areas. And so we see that being a very strong use case. And you can apply that to, as you were talking about, Shelly, in terms of, okay, we've got construction, here's the transportation patterns, here's what we would expect to see. Within our mobility and transportation working group, for instance, looking at it from a traditional hub and spoke type approach and being able to understand what is the impact of different transportation scenarios in terms of being able to support, the delivery of goods, and people from that perspective. So no, these are all great points. I think we had a couple questions. I'm not sure, Barbara, did you? I don't know if that had still continued through here. Let me see.
I tried to kind of take them offline because I think I've lost the thread also, but I think actually he answered his own question with his second question.
Well, I saw a comment.
Yeah.
The comment was, so isn't position stationary, right? Isn't location. So now we've solved the problem. And I don't think that, I don't think the panelists here would agree with that that's going to solve the problem, because it is constantly changing. It is very dynamic and it is evolving, continually evolving.
The objects move.
Yeah, exactly. It's exactly. So, but I didn't catch the follow-on that you said where they answered their own question. So that's fine. But,
yeah, I actually made that same point about just how much everything changes on the land.
Exactly. All right, excellent. Now, well, I see we're coming up on our 45-minute mark here. So I just want to thank all the panelists, and again, opportunity to be able to moderate this in these different areas and share these insights. So pleasure. Thank you very much.
Thank you.
Yeah, Dan, you did a great job. And actually, each of the panelists, you guys have got just really thoughtful, long-ranging advice and remarks. So thanks so much for that. And I love the fact, well, some validation. I think it was you, Peter, validation about the curve of disillusionment. And then with both, Shelly and Bill coming in, it, just really did talk about, what we've got to do, if we want to kind of move up that curve a little bit. So thanks, you guys. Nice job.